Section 13.5 is volume and mass. Excuse me. And so the first part here we have the volume of a rectangular prism. And so the formula for the volume of a prism is the length times the width times the height. And so our first problem here just says, let's find the volume of a box with sides 22, 25, and 23. Okay, so the formula again is length times width times height. So we're going to take 22 times 25, times 23. So let me take my calculator, let me turn it on, clear this out. 22 times 25 times 23, and I'm coming up with 12,650. Our units, y'all, are going to be meters cubed. Anytime we're dealing with volume, volume always has cubic units, meaning either meters cubed, centimeters cubed, feet cubed, something along those lines, okay? So here's the next one. Here's a formula for a right pyramid, and it says the formula is the volume is equal to 1/3 B times H, where B is the area of the base, okay? So it says find the volume of each figure. So I'm going to write this out here. V equals 1/3 B times H. Okay, so let's see if we can figure this out. 1/3 B, remember B is the area of the base. It's going to be the area of that piece there. So that's going to be 4 times 4 times our height, which in this case is 5. Okay, so this is going to be 1/3 of 4 times 4 is 16 times 5. Okay, I'm going to grab my calculator again. So first I'm going to do what's 16 times 5, and I'm coming up with 80. So I'm going to write this as 80 over 3. My units here are in centimeters. So this is going to be centimeters cubed. Okay. And here's the next one. We have the formula for a right circular cone. And here's my formula. The volume is equal to 1/3 B times H. Remember, B is still the area of the base. Since it's a circle, the area is pi r squared. Okay. And we want to see if we can find the volume of this one. So let's go ahead and do it. 1/3 times pi r squared times H. So 1/3 pi, let's see, our radius in this case is 6 squared. My height is, we don't know the height just yet. Okay, we got to find the height. So let's do that first. We have a right triangle right here. This is our hypotenuse. That's our C, right? Let's call this A. We'll call that B. So I'm going to do a little bit of work over here on the side. So again, we have A squared plus B squared equals C squared. And so we know A is 6. We don't know B, and we know C is 10. So 6 squared plus, we'll just call it H squared, since that's what we're calling it, is equal to 10 squared. So this is 36 plus H squared is equal to 100. So we're going to subtract 36 on both sides. Okay. H squared is going to be equal to 64. So when we take the square root of 64, H is going to be equal to 8. Because the square root of 64 is 8. So that's going to be 8 right here. Okay. So now we're going to have 1/3 pi. Let's see, we said 6 squared was 36 times 8. Okay. So when I take my calculator again, what's 36 times 8? That's given me 288 pi all over 3. And we can actually divide 288 by 3. And so we come up with 96 pi. Our units are in centimeters, so this is centimeters cubed. Again, since we're dealing with volume, volume always deals with cubic units, okay? All right. We have the formula right here, guys, for the volume of a sphere, and it's 4 pi r, 4/3 pi r squared. You know what? There's something off there. Hold on. That doesn't seem right. Okay, so yeah, there's a mistake here, guys. This formula, almost correct. The volume is 4/3 pi r cubed. I don't know why I had square there. Okay, that was my mistake. So fix that right now. Okay, so it says find the volume of each of the following figures, completes parts A through E below. Okay, so we have a right circular cone with a hemisphere. So we have half a circle, right? So let's see if we can do the cone first. So remember, the formula for the cone is 1/3 pi r squared times h. This is just for the cone part, okay? So I'll put a little c for cone. 1/3 pi. The radius in this case is 7, so I'm going to put 7 squared, and the height we already know, which is 15. So 1/3 pi, this is 49 times 15. Okay, so let's see if we can do some of this work here. So what's 49 times 15? That's giving me 735. So I have 735 pi over 3. And we should be able to take 735 and divide it by 3. And I'm coming up with 245. So 245 pi, my units here is centimeters, so this is centimeters cubed. Now, we need to do the part of the hemisphere. So I'm going to use a little h, or I'll put hemi, okay, for hemisphere. So we know the formula for the sphere is 4/3 pi r to the third, right? 4/3 pi r to the third. We're going to have to multiply this now by half because it is a hemisphere. Okay, so this 2 will cancel with this 4 and give me a 2 here. So the volume of my hemisphere is going to be 2/3 pi r to the third. So this is going to be 2/3 pi. We said our radius in this case was 7, so this is 7 raised to the third power. Okay, and let's see. So let me take my calculator. First thing I need to do is, what is 7 raised to the third power? 343, and I got to multiply that now by 2. Okay, so times 2 is 686 pi over 3. Okay. And so, you know what I'm going to do, guys? Actually, I'm going to take this part right here, which was right before we divided it by 3, because I need to add these two together, and we already have a common denominator, don't we? So let's take 735. Let me bring this over here. Let's take 735, and let's add 686. Oops. 735 plus 686, and that's given me 1421. So this is going to be 1421, oops, forgot my 1, 1421 pi all over 3. And all we did is add this number here and that number there together, okay? And there's our volume. Okay? So let's see if we can do the next one. Here we have the volume of a right triangular prism. So the way I'm going to find the volume here, guys, I'm going to take the base, and the area of the base, and we're going to multiply it by the height. So remember, the area of that triangle is the base times height. Oops. Divide it 1/2 the base times the height. Okay. So we're going to take 1/2. The base is 6 centimeters. They're both 6. Okay. So 6 times 6, this is going to be 1/2 times 36, which is 18, okay, centimeters squared. Now that I know the area of this base, we're going to take, to find the volume, we're going to take 18 centimeters squared, and we're going to multiply it by that length there. So times 10, and that should give me 180 centimeters cubed, because this is also centimeters. So centimeters squared with another centimeters is going to give me centimeters cubed. Okay. All right, so here we just have a regular cone, and remember, we did it for a cone earlier, and it was 1/3 base times height, 1/3. The area of the base we said was pi times r squared, and r in this case is 1 squared, times the height, which is 9. So this is 1/3 pi. 1 squared is just 1, and 1 times 9 is 9. And so now I'm just going to figure out what is 1/3 of 9, and that is 3 pi. This is centimeters cubed. Okay. And let's see, we have another sphere. So remember, the formula for the sphere we said was 4/3 pi r to the third. So this is 4/3 pi. My radius in this case is 11 to the third. Okay. So let me get my calculator. The first thing I'm going to do, what is 11 to the third power? 11 to the third power is 1331. So now I'm going to multiply that number by 4. So I'm coming up with 5324 pi over 3. My units in this case are centimeters, so that's centimeters cubed. Okay. All right. Let's see if we can find the volume of this piece here. So first, let's find the volume of the cylinder. Okay. To find the volume of the cylinder, we're going to take pi r squared, which would be the area of this circle, times this height here. Okay. So I'm going to write it out. Pi, my radius, remember the radius is only half the distance. So that's 80, the radius is 40. So 40 squared times my height, which is 100. Okay. So let me take my calculator. What is 40 squared? 1600 times another 100 for my height. 160,000. So 160,000 with a pi. Okay. Now we need to find the volume of the hemisphere. Okay. If you remember from earlier, we said the volume of a hemisphere is 2/3 pi radius cubed. Okay. So the radius, again, right here, is still going to be 40. Right? So I'm going to take 2/3 pi times 40 to the third. So let me take 40 to the third power is 64,000. I got to multiply that number by 2. So I'm coming up with 128,000 pi over 3. Now I'm going to add these two numbers together. I'm going to add this number together and this one. Okay. So look, let's do it like this. 160,000 pi. I'm going to think of this over 1 plus 128,000 pi over 3. My common denominator here, guys, is going to be 3. So I'm going to multiply the bottom by 3 and the top by 3. So if I take 160,000, 1, 2, 3, and I multiply it by 3, that's giving me 480,000. So this is 480,000 pi over 3 plus 128,000 pi over 3. Okay. Now we can add those two numbers together. Where's my calculator? There it is. So I need to add another 128. Okay. And I'm coming up with 608,000 pi all over 3. And our units here were in centimeters. So this is going to be centimeters cubed. Okay. All right. So you can tell again, guys, these problems, they're a little time consuming. Okay. So again, I try to keep the amount of problems that you have short, so you don't have too many. Okay. So let's take a look at this problem here. It says a rectangular swimming pool with dimensions 10 by 25 is being built. The pool has a shallow end that is uniform in depth and a deep end that drops off as shown in the following figure. What is the volume of this pool in cubic meters? Okay, So this problem, I have to kind of do it in pieces. Okay, I'm going to think of, let me kind of block this off here, and now I'm going to find the volume of this piece here. Okay, so the volume of this piece here is, let's see, we already know that over here is 10, so I know this piece here is going to be 10 as well, right? So the volume of that rectangular prism, remember the formula is length times width times height. So it's going to be 15 by 10 by 3. Okay, and I'm going to take my calculator, I'm going to go 15 times 10 times 3, and that's giving me something like 450 meters cubed. Okay, now I need to find the volume of this piece here. Okay, so the way I'm going to find the volume, I'm going to find the area of that's a trapezoid. Okay, so the way I'm going to find the volume, I'm going to show you how to do it. I'm going to find the area of the trapezoid, and then we're going to multiply it by like the depth. Okay, so you kind of have, or you know, an idea, or the length, whatever. Let me call it the length. Okay, so first thing I need to know is, I already know this piece here is 6. This piece here, guys, is going to be 3 because it was 3 here. Okay. The other piece I need to know is, how far is it from here to here? Well, if the whole piece is 25, and this piece of it is 15, that piece is going to be 10, and that piece is going to be 10. So first off, let's see if we can find, remember the formula for the area of a trapezoid. It's going to be 1/2 the height times base 1 plus base 2. Okay, and again, I'm doing this in pieces. So it's going to be 1/2. The height we said was 3. Base 1, I'm sorry, the height is 10, not 3. Sorry about that, guys. The height is 10, okay, because it's this distance right here. Base 1 and base 2 is 6 plus 3. Okay, I'm just going in pieces here. So first off, what's half of 10? Half of 10 is 5. 6 plus 3 is 9. That's giving me 49. Okay, now, so we found the area of this trapezoid. Okay, we use this distance, we used this distance, and this distance. Now I need to multiply it by that length. So now I'm going to multiply it by 10, and that's going to give me 490 meters cubed. So we found the volume of this piece here, and right now we just found the volume of that piece there. So to find the total volume, we're just going to add them together. 450 and 490, and I'm coming up with 940 meters cubed. Okay, again, it takes a little bit of time to do it, and I gotta go slow, but they can be done. Okay, so like I said, the homework problems, I try to just keep it pretty minimal so you don't have too many of them. All right, so here is the last problem, and it says freezer A measures 2 feet by 2 feet by 5 feet, sells for $350. Freezer B, measures 2.5 by 2.5 by 4 and sells for $500. Which freezer is the better buy in terms of dollars per cubic foot? Okay, so let's do freezer A. So let's find the volume of A. Remember, length times width times height. Okay, so we're going to take 2 by 2 by 5. 2 by 2 is 4, by 5 is 20, so this is 20 cubic feet. Now, let's find the volume for freezer B. It is 2.5 by 2.5 by 4. I'm going to use my calculator for this one because I'm not good at multiplying decimals in my head. Oops. Clear it out. 2.5 times 2.5 times 4. And I'm coming up with 25. So the volume B is 25 cubic feet. Okay. So now it says, which freezer is a better buy in terms of dollars per cubic foot? Okay, so they're asking me to do it. Can I do this in dollars per cubic foot? So freezer A was 350, right? So that was 350, 350, and we had a total of 20 cubic feet. So if I take my calculator, what's 350 divided by 20? And that's given me, it is $17.50 per cubic foot. Now, if I do this for B, B was 500, right? So $500 per 25 cubic feet. So 500 divided by 25 is, this is $20 per cubic foot. So now the question is, which is the better deal? A or B? Well, look, A is cheaper, right? So A is going to be cheaper. So we're going to say freezer A is the better buy option because freezer A cost how much? $17.50 per cubic foot, and freezer B cost $20 per cubic foot. Okay, and so that right there, y'all, is 13.5.